Good morning everyone. In this video we are going to learn about the laws of logarithms. Before we do that, let's have an overview of what we mean by logarithms. Now, logarithm is an alternative way of expressing indices. Take, for example, a number in index notation, say b raised to c is equal to a. This can be expressed in logarithmic form, and that is logarithm of a base b is equal to c. This simply implies if you take the base b and raise it to c, that should give us a. And in both cases, b is the base. Here also b is the base. And then c here is the index, plural indices, and then c here is the logarithm of a. With that background, we can now look at the laws. So I'm going to begin by looking at the three basic laws. So the first one is logarithm of a plus logarithm of b is equal to logarithm of the product of a and b. So this is the addition law. For example, if you have log 2 plus log x, then this implies that you can have it as log 2 times x, so the product of 2 and x. And that is for the first law. The second law, we have logarithm of a minus logarithm of b, and this should be equivalent to logarithm of a divided by b. Let's take an example. If you have logarithm of 10, subtract logarithm of 2, then this should be equal to logarithm of 10 divided by 2. That is 10 over 2, which is just logarithm of 5. The third law, which is the exponent law, we have logarithm of a raised to n. Now this should be equivalent to n log a. Now here the power multiplies log a. Let's look at an example. If you have logarithm of, say, 2 raised to 3, this should be equivalent to the power 3 multiplied by logarithm of 2. Now besides these three basic laws, we have 5 others which are equally important. So let's look at law number 4. Law number 4, if you have logarithm of b to base b, this is 1. If we refer to up here, the definition of logarithms, this is just having b raised to 1, which we know is just b. For example, if you have logarithm of 7 to base 7, this is just 1. So if the number we have here is the same as the base, the result automatically is 1. And then let's look at law number 5. Law number 5 again is an application of this. So we have logarithm of 1, say, to base a is equal to 0. So every time we're finding the logarithm of 1, the result is expected to be 0. This in index notation is just like having a raised to 0 is equal to 1. We know a number raised to 0 is 1. An example, if you have, say, logarithm of 1, say to base 3, then this is 0. We know 3 raised to 0 is 1. It's as simple as that. Then law number 6. If you have logarithm of b to base x, then this should be equivalent to the reciprocal of logarithm of x to base b. So b and x have just swapped positions. For example, let's say you have logarithm of 4 to base x. This is just equivalent to 1 over logarithm of x to base 4. Law number 7. Consider logarithm of x and then the base is an exponent. Then this can also be expressed as 1 over the exponent of a, that is n, times logarithm of x to base a. Let's take a case here. Say logarithm of x to base 8, which we know can also be written as logarithm of x to base 2 raised to 3. 8 is 2 raised to 3. This is just the same as 1 over the power 3 times logarithm of x to base 2. And lastly, let's look at law number 8. If you have logarithm of a to base b, then this can be expressed in terms of the common logarithms, that is logarithm to base 10, logarithm of a to base 10 over logarithm of b to base 10. Let's look at this example. Say we have logarithm of 4 to base 8. This is just the same as logarithm of 4 to base 10 all over logarithm of 8 to base 10. And logarithm to base 10 is just common logarithm, so this is just log 4 all over log 8, which can be simplified further. So simplifying the numerator, we have logarithm of 2 squared, and for the denominator we have logarithm of 2 cubed. Now we can apply law number 3, the exponent law. So this means 2 multiplying log 2, and for the denominator we have 3 multiplying log 2. And that finally should give us 2 over 3 because log 2 and log 2 cancel. And that is the result for that example. Now these are the laws of logarithms, key to the application of logarithms. With this, we mark the end of this video. I want to thank you for watching. See you next time. Bye.